welcome again. Welcome to the solutions to the problem number 3. So let's see what we have. This problem number 3 is actually the combination of the previous two. So that a random sample of n measurements was selected from a population with unknown mean mu and unknown standard deviation sigma. Calculate a 95% confidence interval for mu for each of the following situations. So meaning we have been given the n, x bar, and the variance. Okay, let's see. Let's go to A. So our confidence interval, confidence coefficient is given. So the confidence coefficient is equal to 0.95. So confidence coefficient is equal to 95. So therefore our alpha should be, you can know that alpha should be 1 minus 0.95, right? So it's equal to 0.05. Okay, and therefore alpha divided by 2 should be equal to 0.025, correct? Okay, now let's see. From the table 2, appendix D. So if we want to find the G 0.025, which is equal to 1.96, if you can find this one. We know that 0.025 equal to 1.96. Okay, so the confidence interval is, so let's insert the formula. So the confidence interval should be equal to let's take the accent, x bar, then plus minus z 0.025. Okay, then take this one. The formula is the sigma over. Okay, this is the formula. Okay, now let's substitute with the number. So x bar is 28. So 28. Then plus minus should be, and this one z 0.05 is equal to 1.96. Then okay, we have been given the this one is, I mean, the variance is 12, so it should be like so. Okay, so standard deviation is square root of the variance, so it should be 12 over n. This one should be n equal to 75, so 75. So this should be equal to, now we know that we have the 28 and plus minus 1.96, and so if we calculate the square root of 12 and square root of 75, let's do this in Excel. So equal to square root of 12 and equal to square root of 75 is this, okay? And this one divided by this is equal to 0.4, okay? So equal to 0.4 multiplied by 1.96, which is actually 0.75, okay? Let's take more decimal places. What does it say? So 0.784, okay? So let's do this, and this should be 0.784, okay? And the range, meaning the confidence interval, should be equal to minus and plus of this, okay? So 28 minus this, let's do this. So equal to 28 minus this one and 28 plus this one. So 27.216. So 27.216 and 28.784. Okay, this is the confidence interval. Okay, this is our answer actually. This is the answer. Just giving it different numbers. Okay. Again, what I'm going to do, I'm copying this one, so because I can just substitute the numbers. Okay. So the confidence coefficient, let me see. Okay. So 95% is fine, and n equal to 200, 100, 2, and 22. Okay. So now this is the one we have. Okay. So this is 1.96, that's fine. Now let's go over there. And so the variance is given 22, right? And n is given 200. So which should be equal to, so what is the square root of 22? Let's see, 22 and 200, okay? I'm just deleting this. So, okay, square root of 22 and square root of 200. Fine. Okay, is equal to this one divided by this. This is the number, and equal to this multiplied by 1.96. Sorry, equal to this multiplied by 1.96. Yeah, 0.650. 0.650. Okay, so this is actually 0.650. So the answer should be, okay, this one, okay, this number is, x bar is 102, and here the x bar is 102. So now the range should be 102 minus 0.650, which is 101.35, and 102 plus this. So okay, 102 plus 65, right? This is the range. This is the answer. Oh my gosh, what I have done. So this is A. This is A, right? So let me copy this one. Okay, copy. This should be. Okay, this is our A and this is the B. Okay, and for CD, C and D, you will be doing this. C and D, do it yourself, and I'm giving the explanation for the D. So, as it is saying, here's the assumption that the underlying population of measurements normally distributed necessary to ensure the validity of confidence intervals in parts 1 to D. Explain. Okay. So now my explanation is no. So since the sample size in each part was large, and we have seen that n was in between C, yeah, 70, more than 75, more than or equal to 75. So the central limit theorem indicates that the sampling distribution of x bar. Let me insert the x bar. X bar meaning the mean of the sample population. So the x bar is approximately null. Okay. So we're done with problem number 3. Okay, thank you so much.